Alright, friends, welcome back. I took a little break, rested my voice, drank a bunch of water. So yeah, I think I'm ready to rock and roll now for the kind of even more involved part of doing operations with fractions, which is adding and subtracting. So first, we are just going to go over. We're just going to man. Did that break do anything for me? We're just going to be going over addition with fractions right now. So let me write that up here. Addition. I just realized I could have typed it. My break erased everything I learned about this little whiteboard program. Alright, there we go. So let's come up with two fractions to add. We're going to do like denominators just so I can show you what our end goal is for when we have unlike denominators. So let's do 1/4 plus 3/4. No, I lied. We're going to do 2/4. 1/4 plus 2/4. So with fractions, with adding and subtracting fractions, they must have a like denominator. So these two numbers here need to be the same. And luckily in the example I chose just now, they are the same. And they need to be the same because that is going to be the denominator of our answer. So when we add and subtract fractions, we're actually only working with the top two numbers once we get that common denominator. So now I just add 1 and 2, which gets me 3, and my answer is 3/4. Now that was an easy problem. Let's go ahead and get into one that is not so easy. Let's do 3/8 plus, let's do 5/32. Why not? So the idea here is that we want to get these two numbers to be the same. And in order to do that, we're going to have to work with equivalent fractions. We're going to turn these into equivalent fractions with the same denominator. So best way to do that is we can find that greatest common factor again, or if you know your math facts, which I highly suggest you practice if you aren't feeling comfortable with those, you might be able to see, oh, well, we have 32 and 8 here. I know 8 times 4 is 32. So all I have to do is actually work at this fraction right here to get a common denominator of 32. So let's go ahead and do that. Let's do 3 times 8. Whoops, that was a big 8. There we go. I'm going to multiply by 4 over 4, my 4/4, my special one, because like I said earlier, 8 times 4 gets me to 32, so I'm going to use my special one of 4 over 4. And when I'm getting an equivalent fraction, I have to multiply by a special one. Doesn't matter, what number it is. If I wanted to make a denominator of 64, I'd multiply 8 by 8. I'd have to do 8/8 then, 8 over 8. Just so that I keep the value of the fraction the same. All I'm doing is changing how it looks. So now we're multiplying fractions, so we multiply straight across the top, straight across the bottom. 3 times 4 is 12, 8 times 4 is 32. And now look, I have common denominators here. I can add. So I can take 12/32. I will add on my 5/32. I keep my denominator the same, 32, because we just, sorry y'all, we just did all that work to get them to be common. And now I add across the top. 12 plus 5, I get 17. In your challenge, I'm going to give you a little challenge if I may. Your challenge is, if you are watching this video, I want you to tell me if this is in simplest form, if I have reduced this, or if I could push this into lower terms than 17/32. So if you're watching this, that's your little challenge. I want you to drop in the comments, if you will. I don't know, professional YouTuber, y'all. But yeah, let me know if that could be simplified, and if it can be simplified, what would be the more simplified version of that fraction? So that's addition with fractions. Nothing too crazy. Let's go ahead and do another example though. That's not as neat as this one, because I could use my math facts here. I know how to get to 32 from 8, so I only had to change one of my fractions. What if I had something like 1/3 plus 4/7? Well, 3 and 7 are both prime. Um, so it's not quite maybe as simple as it looks. Some of you might already see where I might go with this though. They're not going to have a common number that I can multiply them by to get, 3 to 7 or get them to something nice. So one method that you can do, and I don't suggest doing this all the time, it might be better to find that greatest common denominator. But one method you can do is simply just multiply. So let me get my highlighter. I can multiply my 3 by 7 and my 7 by 3, because remember that commutative property? I can get the same common denominator that way, which 7 times 3, 3 times 7, I'm going to get 21 either way. So let's go ahead and expand that out. I have 1/3, and I'm going to multiply that by my special 1 of 7/7, or 7/7. There's my special 1, write that all out for you. And now because I'm multiplying fractions, I'm going to multiply straight across the top and straight across the bottom. 1 times 7 gets me 7. 3 times 7, we did that up here, gets me 21. So there's my equivalent fraction for 1/3. An equivalent fraction for 1/3 is 7/21. Now I can take my 4/7 and I'm going to multiply by the opposite. I'm going to multiply by 3 now. I'm going to make a special 1 of 3/3, 3/3. I'm going to multiply straight across the top, straight across the bottom. 4 times 3 is 12. 7 times 3 is 21. So now I have an equivalent fraction for 1/3 and 4/7 that have a common denominator of 21. So now I can actually add these. I can take my 7/21 and I'll add my 12/21. And we just did all that work getting the same denominator, so I'm going to keep it for my answer. And now I just add across the top. 7 plus 12 gets me to 19. So now I have a final answer of 19/21. So that's adding fractions. The main thing to remember, and I'll even type this out right here. So the main thing to remember is that the denominators, the bottom number of the fraction, must be the same in order to add, oops, if I can spell, there we go, in order to add fractions. So the denominators must be the same. We have to use our skills of multiplying fractions and finding equivalent fractions in order to add fractions with unlike denominators. If we get lucky and we have a problem where they have the same denominator, it's as easy as keeping that denominator for your answer and adding the numerators to get your numerator for your answer. All right, let me go ahead and clear this space, and we will jump into subtracting fractions, subtraction with fractions. It kind of has a little ring to it, doesn't it? All right, there we go. So let me go ahead and write that big up here like I did with addition. I could type it, but for the sake of just keeping it the same, because I don't know, that's pleasing to me. Subtraction. Is my handwriting getting better with this or worse? I can't tell. All right. So just to keep it kind of straightforward and explain to you the process, we're going to start with two fractions that have a common denominator, the same denominator. There we go, if I can speak. So let's go ahead, let's do 3/4, keeping in mind with using fourths as my example. Let's do 3/4 minus 1/4. Same as with adding fractions, we keep the denominator the same, and we just subtract across the top. 3 minus 1 gets me 2. So let's go ahead and do an example now with unlike denominators. Let's do 7/8, and let's subtract 2/3. So again, let's just go ahead and use my method of multiplying by the opposite denominator in order to get that common denominator. This is probably the easiest method to do because it kind of involves the least amount of math, quote unquote. I do suggest that you find your greatest common denominator, same way you find your greatest common factor. And in this scenario, actually, when we flip-flop and multiply 8 by 3 and 3 by 8, that is actually going to be our greatest common denominator. Sometimes that's not the case when we do this flip-flop method, but it's kind of an easy way for students to remember how to do this. So I do suggest that you do it. So we're going to do 7/8. We're going to multiply by our special 1 of 3 over 3. And just to kind of do it all at once, I'm also going to set up my 2/3. I'll multiply that by my special 8 of 8 over 8. Or sorry, my special 1 of 8 over 8. I misspoke there. So you see how I'm just kind of switching the denominators and multiplying them so that they get to the same number. 8 times 3 is 24, so I have a common denominator of 24 now. And I'll just multiply straight across the top. 7 times 3 is 21. 2 times 8 is 16. So now I have equivalent fractions for 7/8 and 2/3 that have a common denominator of 24. I can finally subtract. 21 24ths minus 16 24ths. So just like with addition, we did all that work to get a common denominator. So we're going to keep it for our answer. And now I just subtract across the top. 21 minus 16 gets me 5. So my final answer is 5 24ths. So nothing too crazy with adding, subtracting fractions. It's just kind of extra steps because you have to make sure, and I'll type this out again, that they have that common denominator. So when adding and subtracting fractions, they must, all caps, have a common, which means the same, denominator. They must have a common denominator. We cannot add and subtract fractions if they have unlike or different denominators. We have to get that bottom number the same through creating equivalent fractions, and only then can we add and subtract those fractions. So again, this is just going to be repetition, doing lots of problems like this and making sure that you're doing all of the proper steps. This is a good method right here of just using the other denominator to create a special one, and you know for sure that you'll get the same denominator that way, because like I said previously with the addition commutative property, I can flip what I'm multiplying and still get the exact same number. As always, if you need any more help with this, you can reach out to me. Delete all that, there we go. And I'll put my email. Oops. There we go. So you can email me at mbailey@pmi.edu. If you want to send me like a picture of your work and you don't know where exactly you went wrong, I can parse through it and find wherever the error or mistake was, and I can let you know where that breakdown was, and I can write down on a piece of paper exactly how the work should look and explain everything, and I can scan it and email it back to you, or you can set up a time to meet with me. I do also currently have tutoring hours. Again, if you're watching this later in the future, hello from the past, by the way. Double check, make sure that these are correct. I will probably already have them posted in Blackboard for you. But currently, as of recording, my tutoring hours are Tuesday. I will be in the career prep classroom. Oops. Let me expand this. There we go. I will be in the career prep classroom from 5 o'clock to 6 o'clock on Wednesday. I will be in room 402 from 12:30 to 1:30. And on Thursday, I will be back in the career prep classroom from 5 o'clock to 6 o'clock. So hopefully something there works within your schedule and you're able to swing by if you want any further assistance. If not though, I am very flexible and workable. We can figure something out within both of our schedules that works, and we can get you that extra help if you feel like you need it. But yeah, let's see how long this one was. How we doing? Oh, almost 15 minutes, y'all. That was so much better than an hour-long video, right? I went through less examples, explained maybe a little bit less this time around. So if things weren't very clear, feel free to leave a comment and maybe I'll record another video about adding, subtracting fractions if you feel like I could cover this a little bit more in depth. But with that being said, yeah, bye. I guess I'll see you guys in the next one.